Hey everyone, welcome back. Got another episode today. I kind of jumped ahead and did some of this offline because a lot of it's kind of grinding. But in the last episode, we focused on how we could do composite events, and we created a new state machine that provided a thank you experience for if a person reserves a book and we want to then check it out. We wanted to thank them, and it was kind of a hypothetical situation of how to do composite events, and it got me thinking. All of the testing that we've done so far has been very much in memory. I mean, we've done in-memory tests, and in the back of my head, I'm thinking one of the common questions, and I went back through Stack Overflow, and I look at a lot of the questions, and Discord is great because it keeps history forever, and I'm able to search back like into June, which is really cool. By the way, I'm Chris. I should do an intro, but I don't have time for that. I skip over those when I watch YouTube videos anyway, so who cares? That's what L is for. Skip over those segments. The key thing that I wanted to think of in this episode is, okay, I want to move to an integration testing phase. Hey, welcome to the chat, Brave Cobra 2. Hopefully some people show up tonight. I started posting in Twitter when I go live because that way at least people can see it. I know they get the Twitch notifications, but it's good to have just kind of another thing so we can get people to show up. It's more fun when there's people in the chat asking questions. So what I did is offline because honestly, creating a new project and figuring out how to get Entity Framework Core to work, while I'm sure somebody finds that interesting, I find it frustrating every time I do it. So what I've done is I've gone in and created a library integration tests project within the solution. And if we look at the dependencies on this, you can see we have MassTransit Entity Framework Core. Oh, FYI, MassTransit 707 was released earlier today, and I've already upgraded the sample to the latest bits. So everything still works. It was a great way for me to test it out. And it lets me kind of show some of the new features that are in 707 as well. So that's going to be another nice little perk of this episode, is you're going to get to find out about some of the new capabilities that I've recently added. So as you can see, I've added Postgres as the database, and I'm using Entity Framework Core. And within this integration test, I have a Docker Compose YAML, and that Docker Compose has just a simple Postgres 9, simple user and password for SA, just so we have a Postgres instance running. And if we look out here, and I think it's probably one of these, yeah, here we have Postgres running inside a Docker container. So we're all good to go there. We're going to be all set. It's going to be awesome. Now, setting up integration tests with EF Core is a little weird, and I leveraged the MassTransit tests as kind of a cut and paste cheat sheet, but hopefully this kind of gives a nice isolated sample if you're just using a single database. So within here, the only database that I've created a mapping for so far is the thank you one. And you can see that I created a Saga class map for the thank you class. And that lets me configure the entity. And in the last episode, I talked about things like indices. Well, here I have an index. I have the book ID, member ID properties, and then I have an index on book ID, member ID that's unique. So I've created that index so that if I try to insert the same thing at the same time, I would get a duplicate check, and we can cover some of the error handling scenarios of that later on. I've also mapped the reservation ID property and the thank you status. You don't have to map the basics like correlation ID and current state, because I think they're mapped automatically for you. Although I don't see current state, which is weird. I see the correlation ID, which is good. Did I not map current state? Maybe I need to map current state. Okay, something new every day. I guess we'll find out if we get an error. It worked before, so I'm guessing we'll find out shortly. I don't know that you need to do that, but it is an int, so anyway, yeah, we probably do, because you probably want to specify the field length. Anyway, nonsense. Let's move on. So I have the class map for that. And then that class map itself is inside what I've called an integration test DB context, which is derived from Saga DB context. And the only thing it has is a set of configurations of Saga class maps. Right now I just have one, and I'm going to return that back out to, and then the base Saga DB context as the appropriate setup for that for you. So that's all part of the EF core integration library. That integration DB context, to get that to work with Entity Framework Core migrations, we use the design. I use the design assembly, and I created a design time DB context factory. I don't know why I do this, but I think it's because of the way migrations work. But in here, I specify that Postgres is the database. I set up the migrations assembly. I set up a history table for it. You can see I have the user ID Postgres with a password. I put a database name of library integration test, which it's going to create. All of that's going to get set up. So that's just like the boilerplate grunt of getting .NET Core EF to work. Then you go out to the command line. You do things like .NET EF migrations add, give it a name. It'll take that DB context, create a migration for it. And then what I've done is I've copied over our state machine test fixture from the components test, which was in memory, and I've made a few tweaks to it. First of all, I've come in here and I've added the migrate up and migrate down sections. And what these allow us to do is to use the DB context factory to create the DB context and then do a migrate async and then a delete. So this lets us create the database for when the unit test starts and then nuke everything when we're done. And then I've added in the setup and teardown of the test fixture, the call to migrate down after the test is done, and the call to migrate up when the test is set up. You'll also see that I've done another little fun thing in here. And I've configured this in the new way of configuring Saga contexts for EF, because I only have one state machine right now, but if I add the other ones to the unit test, I want to be able to put those in here without adding the DB context more than once. So in this case, I add the DB context to the container, and I call the DB context factory apply, which in this case is going to apply the Postgres settings to it. And then within the add in-memory test harness, so I'm still using the in-memory test harness, but I'm using a real database to test the database interaction. I'm telling it to use the Entity Framework repository. I'm setting the lock statement provider to Postgres, and I'm specifying to use an existing DB context from the container, and that's the integration test DB context. So that's really all I've changed from the other test fixture. The other one did it in memory. Just by changing the repository I'm using, I'm able to still test it, but with that database-backed repository. So pretty cool. But that gives you an idea of what we have to do to get this working. Everything else is the same. It's all in memory. And now let's look at the thank you specs test. Now this is the exact same thank you specs as from the other file. And I ran into something that I thought I had fixed in an earlier version, but I guess I hadn't. So I made a note for myself to go fix this. In the other tests, we were using the test harness.exists method. And one of the problems that people frequently encounter when testing is those exists methods. And let me go to one of those because I feel like it's something that I got caught up in, and it would have been a great thing to show live because it was frustrating as hell. But you can see in here, we're using the saga harness.exists method for the tests. And if I run these, they all still run because they're still using the in-memory Saga repository. And if you remember the in-memory Saga repository, well, it runs in memory. It's using a materialized class-based version of the Saga. So when exist runs, what it's actually doing is it's kind of cheating. And if we go in here, we're going to dig into some MassTransit source code here because that's always fun. When it calls exists, it's doing something that's really annoying. It's setting up a Saga query with correlation ID equal to correlation ID and state machine.getState instance.result. Well, this is like an async method with a dot result. There is no way a link query parser is ever going to figure this out because it just won't map to anything. It's for lack of a better word, me being dumb. It worked great for in-memory testing because that's all that was previously used for, but now that we're able to do container-based and nice extensive integration tests, exists isn't going to get it done for us. So I'm going to have to fix exists, and that'll be in 708 or whatever, not a big deal. But I had to change because I knew I had written this somewhere because I actually had to rev automatonomous to do it. And the place I had done it is in the should contain Saga in state method that is an extension method to iSaga repository, which, again, I'll get the harness updated so it exists, works like it should. So I changed these tests to actually resolve iSaga repository from the container. And then the should contain Saga in state method, if we actually go and look at it, it does something a little nicer. And there's like 85 overloads of this, but it goes out and calls machine.createSagaQuery. Now, this was a new capability that was added maybe in 7.06, possibly a version earlier, but it's definitely there with the latest. And what createSagaQuery does is you can pass it an expression and a state, and that expression can be any link compilable expression. And what this will do is it will actually go out and get a state expression for the states that you've said the Saga can be in, and combine that. So it does some expression magic to combine that state expression with your link query expression to get a composite expression. So it's building the expression in a way that a link parser is going to work instead of putting some weird async task caller in there. So this was added. This will eventually work and exist, but you can use this anytime you want if you have a state machine to create an iSaga query, and then you can use the iQuery Saga repository interface, which you can cast any iSaga repository to that, and it'll work for every Saga repo except for Redis. And that will let you create your own query expressions against a Saga repository for just arbitrary queries against the database. So kind of a cool feature, isn't really well documented. This is probably the first time I'm talking about it. But the create Saga query method off of state machine is great for just taking an expression and then saying these states are what are valid, and then having that add those in there. So pretty cool. You can pass any Saga query to that. This one just does the math for the expression building for you. So we updated that test to use should contain Saga in state so that it actually works. I've taken all the other cruft out of here because we test that elsewhere. Here, all we're really wanting to test is that when we push these through a real database, that it actually works. And if I run this, I will see it run. You'll see some setup. Because I'm outputting everything in the logger, I see everything Postgres writes. So we'll open this up in a full test and kind of close this down. And you can see where it's running the migrations, it's creating the databases, it's doing all of its work, it's initializing the tests. I mean, all the stuff is in here. You can see where it's doing the selects against the database to find existing Saga instances, you know, the add the used, all that stuff is in here. And so we're able to do that against the database. You know, for instance, here's one of the Saga used log messages after it's gone and done an update against that. So pretty clever. We're able to test that against an actual real database, which means we know our class mappings work, things like that. And that is basically the nuts and bolts of getting that working. Now, so that's the first step, and now we're able to test that. We can test that with SQL Server. We could test it with anything. We just have to configure the DB context properly. The other piece I wanted to show is new in 7.07, and it's in the release notes and in the documentation. A pretty commonly requested thing is, well, let's just look at how we want to do this. Some people have asked, how could I execute handle an event in a Saga without locking the database and updating the Saga version? So when you use an optimistic concurrency store like Mongo or Redis doesn't do queries, but it does do correlation ID lookups, or any of the ones where we have to go back and write out, Azure Table Storage, Cosmos DB, anything that we do optimistic concurrency with. It's important that we have the ability to not lock and not update, because a lot of people are doing queries and read-based events in their state machines. So for instance, a web UI may come in and say, hey, I want to send a command to a Saga to see if it's still running. And it doesn't want to go read the database directly because it might be in, for whatever reason, you don't really want to share, use shared database as your integration method, especially when you're using a Saga. So I want to send a message to the Saga and have it respond with that current state. So what I thought I would do here is I would go to the thank you state machine, and I'm going to add, well, first, before I jump into that, let me show you one more little thing. So right now, the way the state machine instances are correlating is it queries out to see if there's one there, and if it isn't there, it creates a new one. With this event correlation, you can also specify, well, I'll get back to that. Let me continue where I was. So what I'm going to do is I'm going to add an event called the getThankYouStatus. And all this is going to do is I'm going to pass a member ID because that's all I know. And I want to see if there is a currently active thank you or if we've sent a thank you for that member. And so I've added the event in here. I'm going to handle the event because I don't care when it happens. So I'm going to say during any, when getStatus. And I'm going to respond async with the thank you status, which is just member ID, book ID, and the actual status as a string. Now I'm initializing this using a message initializer. So I'm using respond async to respond to the request, just like we did in the previous video. But I'm doing a couple weird things in here. And some of this explicit stuff annoys me, but I'm going to get over it. I want to be able to, so again, because the state is an int in the class, we don't necessarily have the name for it. And one of the properties of the state machine is an accessor. And apparently for some brilliant reason, I thought it would be awesome to make it explicit. And I probably made it explicit because when you're defining the state machine, if it shows up in the autocomplete, it kind of confuses things. But anyway, so I cast this to state machine of thank you, and then I get the accessor. What the accessor is a state accessor for an instance of the state machine. And this is async because there are a number of reasons why that happens. But when I call get returns a task of state in which I pass it an instance. Now, one of the cool things about message initializers is if you pass it any tasks and it knows that the appropriate type is a string, so like status is a string, and the initializer is going to know that. And what I'm actually passing it in that through the anonymous object is a task of state thank you. So MassTransit initializers know how to translate data, and they can transform a lot of different data types. And one of the things they do is if you pass a task, it will await that task as part of initializing that message and then use the task result to initialize the status property. And since the status property on the message contact is a string, it's going to try to convert the state of instance to string using, you guessed it, toString. So it's going to use the toString method, which states will return the actual state name to. And so it's really just kind of a clever way for me to get the state and return it as a string all through the asynchronous way. I could just as easily just await it and check it and return a couple values. It doesn't matter as long as it's a task of whatever. I could call a remote function that returns a task that returns a blob string, and it wouldn't matter. I can do any of that in an initializer. So once I've declared that, I actually need to go up and actually declare my event, and don't mind those insert on initials. I'm just undoing my changes. We'll take these off for now because I want to cover that later. So I add the correlation for this, and in this case, I'm orally correlating my member ID. I don't need a select ID because I'm not going to initialize the instance. During any by default does not include initial, so if one of these doesn't exist, it's going to return a not found. And in fact, I probably should, to handle the request handler, I probably should put an on missing instance of something like execute async. What's this going to be? Context.respond to async. And I probably should put another one of these in here. Do autocomplete. Let's just do this as respond to async context. I got like 80 million parentheses here. I have no idea how many I need. There's way too many parentheses here. Too many? Let's see here. I don't know how many I need. Okay, yeah, I figured out how many I need. Why is respond async unhappy here? Oh, because I'm not within a state handler, so here I just do this. Okay, that's why I was freaked out. Then I can do this, context.respond async. Because I don't have an instance, I would just say status is not found because I don't have the book ID. We'll just do that for now. Whoa, hey, don't go jumping around. Okay, there we go. So we're just going to return a simple not found. So the on missing instance there is so if we don't match to an instance for some reason, we'll actually just dump them out, which is great. I think it works. We'll find out. I don't actually test that case, so not a big deal. But here I've set up the get status so it correlates to an instance. And during get status, I'm going to respond with that type. Now, in my unit tests for thank you specs in the integration, I've put a should handle get status checks. And one other change here I've done is, let's see here, question. So the query is just an event that is handled without a transition and responds by sending a new message, correct? Yes, that's what it is. And in fact, I forgot one key part of that. I forgot to also put x.readOnly equals true. And so by setting read-only equals true, it is not going to ever update that instance. I hope. It should work. It's new in 707, and I tested it, so it should work, right? So with read-only set, it will never go out and update the database. So if it's tracking the entity with EF, it tells it to stop tracking it. If it's an optimistic database like Mongo, it won't send the replace command to Mongo. It'll just ignore it. The catch here is that if you're using the in-memory Saga repository, you're modifying state directly on the instance in memory. So read-only does not work for the in-memory Saga repository. Sorry, we don't have state transactional memory and everything inside .NET, so it's just something we can't do. And I'm not making copies of objects and doing virtual tracking and all that. That's insanity. So recognize that limitation and live with it. It's all good. If I did a transition in here, it wouldn't work. And I could show that as part of the test. But for now, let's check our first test. So we're going to go out here. And what we're going to do is we're going to send the book checked out to put it into a state of active. You'll notice one other thing doing here. Using the initializer, I'm also setting a message ID. So because we set in the state machine, because we said, hey, if we create a new instance, use the message ID to create it. To support my tests, I wanted the Saga ID to be consistent for testing so I could read it from the database. So I'm actually setting the message ID header to that Saga ID so that I have that. Another thing that I figured out actually does work, which I thought it did, but I wasn't positive. I was always afraid to try it. But previously, I used to do things like book ID equals book ID. Well, the initializers are case insensitive because the runtime is case insensitive for property names. And even though C# is, I think the runtime itself isn't. But anyway, it doesn't matter. With JavaScript, it's going to go into lowercase anyway. Because that's case insensitive, there isn't any reason to assign that a name. Just put those in there. It makes it shorter, cleaner, easier, much greater. Just little things that I notice as I use the system. And in this case, so I'm going to check that the Saga actually gets there in the active state. And then I'm going to create a request client and send that request to get the thank you status. And I'm going to pass the member ID that I have because I want the member ID. And now I can just pass member ID in lowercase because it will initialize properly. And then I'm going to assume that the response is active state. That's what toString returns for that. Then I'm going to publish book reserved, and I'm going to get the exact same thing. So when I run this test, hopefully it'll work. I kind of just undid my changes, and hopefully they actually show up properly. Yeah, so here we have and this is like gnarly to read in the full text output. I can't really find it all, but if we go and look where the search by member ID is, book ID, member ID, book ID, member ID, here's where it's actually doing the query to say, okay, well, I want to find the thank you where the member ID is this. And if you look, we do begin a transaction. We do load it up. We load the Saga instance, but then we just throw it away. The data reader was disposed. It didn't try to do an update. It didn't deal with any changes. It was just gone. So it didn't try to update the database. And we can verify if I come in here and we do the get thank you status. we could also just put an additional check in here to verify that it's still in the active state. And let's go to the thank you state machine and say when they get status, let's just create some weirdo status called, you know, invalid or whatever. And let's put a transition to invalid and try to transition to that state. But because we have read-only up here, it should never get in that state, because it isn't going to write it back out to the database. And if we go look at the log, we won't see an update. And that was wrong. Why did it transition to that state? I'm a moron. So it's good to see this because, you know, these are the kind of things that are fun. So because I put the transition to up here, I'm actually responding with the current state, which currently is invalid. And if I move this to the proper place, which is actually down here, after I respond, now the test will pass. Okay, now the test passed. And if we go in here and we look at the test output, we can see the, oh wait, member ID. Yeah, member ID. Oh, now I searched for M. That's awesome. So where we queried for member ID, we can see that we never do an update, whereas before we would do an update after that. So we query for member ID. It's great. It's not there. Never gets updated. Never gets updated in the database because we never write it back out. And do we get an update? Where does update happen in here? Yeah, so here first we set update, set current reservation, thank you status. Here we do another update where we're just changing the thank you status. Yeah. Oh, for update. Yeah, so we select for update, but we don't actually do anything with it. So great, because we didn't change it. So that's the approach for that. And again, we did the transition too, but it doesn't do anything. We'll take it out because that's kind of annoying, but just to show that it does in fact not save the changes when you put read only as true. Great. So the one other piece that I wanted to cover is currently, again, if we go and look at the test results of that, when we open the full test output, we can see that when we first create a, this is our checking for the existence, but when we first create the database and we first execute the command, you can see that we have a command where we do an insert into, and then we do a select with the correlation. Where's the select with the member ID? So we do a select, that's where select where member ID is this. There should be a select with our actual query type. Okay, so here's our first select, I think, where member ID and book ID equals the same. And so when we have this select here where it's like where member ID and book ID, this is where it's actually executing our query. And here's the first time up at the top. So the first time we're executing our query, there's nothing really above that. We created our migrations and then boom, we immediately do a select, try to find that Saga query, and we find nothing. We get no rows back. So because this current state, that's when we're checking for the existence of it. But here where we're asking for it is we're trying to load that instance in. And we didn't find one. So then we're going to go and create one and we're going to add it. And that's going to actually create the instance and do the insert, which for some reason I don't see that, but it tracks it anyway, because we're done by then. We did the transaction. It's weird how it doesn't put the inserts on there. Maybe it's a logging option in Postgres. But anyway, if you have a lot of contention, and this really only works with transactional data stores where you're using like a serializable isolation level, one of the things that we found in a performance-wise category is that if you're doing a lot of selects against queries and then doing inserts, you can get some pretty weird range locks in SQL Server, and these can seriously impact performance. Because basically, SQL is going to, even though it's row locking, it's going to prospectively lock ranges of a clustered index so that you don't, it's just something weird that it does. And we saw this in production many times. So what we did a long time ago is we added the ability to say insert on initial for an event within a state machine. And the reason we did this is because it's actually faster to insert and get a duplicate insert error for an index than it is. And since most of the time you're probably inserting something new anyway, and this is, you wouldn't necessarily always use this when you're correlating by a query, but if you know the GUID and the GUID is going to insert a new instance, you almost always want to use insert on initial. And the reason it isn't doing anything in this is because I'm not doing it by ID. In this case, it should, because it has the ID of message ID. But the entire point is that if you have multiple competing consumers, and it isn't for the same GUID, they're completely different GUIDs. You could have a range of 100 GUIDs. And if you had all those concurrent inserts going on, you get these really weird range locks, which can really limit throughput of inserting rows into the database. So by just trying to insert it, question in the chat, is that only SQL Server? Maybe. I mean, databases do weird things, and when you're doing mass amounts of inserts, they're going to do some tricks to do their things. So this will work with any database that supports insert, since all the Saga repositories are consistent now. The only caveat is that you need to make sure that your Saga instance can be uninitialized when you do this insert. And so that can create some problems in the case of this one, where like book ID and member ID are not initialized, they're going to be 0. So this isn't a great example, but if you had the GUID and a bunch of nullable properties, so for instance, if I would have to create a migration if I did that, but I should have created like book ID and member ID and everything is nullable to use initial inserts. But if you see yourself getting performance problems with Sagas where you're doing a large number of inserts, try the insert on initial if you're doing a GUID-based correlation and you have that assigned identifier, and it might speed them up. So anyway, all this is going to do is it's going to try to insert the row up front instead of later. You won't see any difference in the run. It'll run the same. It's just instead of that initial query, we should see. So if we do a search again for that initial value, we should have already done like an insert against it. But I think because it's doing a query, it doesn't work. So it has to be one that correlates off an ID directly. So correlate by ID instead of correlate. And we could do a test with that with another one of the state machine types, but we're already at time, so I don't want to drag too much out. But anyway, insert with initial, all it does is it always tries to insert if it's in the initial state. So if it's in the initially block, it will always try to insert. And then if the instance already exists, it will have to be in a during block. So typically you're going to have an event that supports insert on initial in both your initially and your during blocks within your state machine declaration. So that's what I wanted to cover now is, integration testing. I'm going to push this up to the repo, so we'll have that available. How to test it with a Saga repo using the same test harness we were doing. A little touch and go with some EF migrations, how to set up the DB context and how to configure the Saga repo, and then how to do read-only events against that so that you can do queries against the database in an optimistic concurrency scenario and not do that subsequent attempt to write back out and getting that DB concurrency exception. Because there's nothing worse than you're trying to do a request. You've already sent the response, and then you get a concurrency exception and it tries to reprocess the request. I mean, let's just face it, that's dumb. So this gives us a new capability. It's new in 707, and the read-only is pretty legit. So that's all I got for tonight. Hopefully this was informative. There'll be more to come. I've still got to cover things like exception handling, and I think I thought of something just earlier, but I can't remember what it was that I needed to get to at some point. But stay tuned, and appreciate you joining. Talk to you later.